The bob of a simple pendulum has a mass 2 gram and a charge of 5 microcoulomb. It is at rest in a uniform horizontal electric field of intensity 2000 volts per meter. At equilibrium, the angle that pendulum make with the vertical is G can be taken as 10 meter per second square, and options are given tan inverse 2, tan inverse 0.2, tan inverse 5, tan inverse 0.5. It's a question from JEE Main 2019. See, all of you look here. Here assume that you have a bob hanging from a roof. See, if the bob is in an electric field, okay, assume that the bob is having some charge Q, okay, assume mass M is there, charge Q is there, okay. If that is the case, you know that, like you know how mass in gravitation field is under the action of a force, there will be a force acting on a charge carrying particle when it is kept in an electric field. That is the idea. So you know that F is equal to mg, the force, gravitation force is equal to mass multiplied by gravitation field intensity actually, or G we can say. F is equal to Q multiplied by electric field in the case of a electrostatic force, or when you are keeping a charged particle in a electric field, QE charge force will be acting. So here, given that a uniform horizontal electric field is there in a horizontal direction, so that means 2000 volt per meter electric field is there. So here, some force at equilibrium, you know, there will be some force acting in this direction. So there is some force acting in this direction, okay. That is because of the electrostatic force, okay. Now, in the downward direction, you know, there will be gravitation force acting in the downward direction, and there will be tension acting on the string, okay, tension acting on the string. See, all the charge, mass, electric field, everything is given in this case. Now, you know that if you are considering this, see, with vertical, see, assume this is a vertical, here also we can do the same thing, okay. So we can say that there will be some angle here. So this, assume this is theta, okay, this is also theta. What is the condition for equilibrium? When a body is in equilibrium, you know, sigma of Fx should be equal to 0, sigma of Fy should be equal to 0, again sigma of Fc should be equal to 0. If we satisfy these conditions, we can say that the body is under, or the system is under equilibrium. Here, you know, tension is acting in this direction. Here tension T is acting in this direction, and the force, you know, because of the electrostatic force F is equal to QE is acting in this direction, okay. And here, you know, gravitation force in the downward direction F is equal to mg is acting, okay. The question is, if the system is in equilibrium, how much is the angle, okay. Now we can resolve this tension into two different components. We can say that one component of tension will act in the positive y direction, and another component will be acting in the negative x direction, okay, negative x direction. So here we can say that here t in the y direction, that is nothing but, you know, the projection t cos theta. T cos theta will be acting in the positive y direction. Already, you know, this F is equal to QE is acting in the positive x direction, and F is equal to mg is acting in the minus y direction. Similarly, we can say that T sin theta component, T sin theta will be acting in the minus x direction, okay. So when you are applying the equilibrium concept, if the equilibrium is applied, we can see that we'll get final equation. See Fx, when you are applying the concept of sigma Fx is equal to 0. Sigma Fx is 0, the sum of all forces acting in the x direction is 0. In the positive x direction, you have QE. In the minus x direction, you have minus of T sin theta. So that should be equal to 0 if the force is in equilibrium, if the system is in equilibrium. Or system is in equilibrium means net force acting in all directions are 0. So here we can equate T sin theta, we will get an equation. T sin theta is equal to QE. Let us call it as equation number 1. Okay. Similarly, when you are applying sigma F of y is equal to 0. In the y direction, you know that T cos theta is acting in the positive y direction, and minus of mg is acting in the downward direction, because minus y direction, that should be equal to 0. Or we are getting another equation, T cos theta is equal to mg. Okay, equation number 2. If I am dividing 1 by 2, okay, 1 divided by 2, you will get, see, T sin theta divided by T cos theta is going to give you, how much is that? QE divided by mg. Okay, so this T will be cancelled out. So sin theta by cos theta, tan theta. So tan theta is going to be equal to QE divided by mg. Okay, all the values are given. Q is given as 5 microcoulomb, E is given as 2000, G is 10 you can use, mass is given as, how much gram is given? Mass is given as 2 gram. You can substitute everything in SI unit. Okay, let us do that. So Q is 5 microcoulomb, 5 into 10 to the power minus 6 multiplied by 2000 volt per meter, 2 into 10 to the power 3, okay, divided by, how much is mass? 2 gram, right? 2 multiplied by 10 to the power minus 3, we are converting that into SI, multiplied by 10. Okay, do the math here, it's very easy, right? See, here you can see that this 2 will be cancelled out first of all. Okay, now you can see 10 to the power minus 3, here minus 3 will come when you're cancelling out. Again, this will get cancelled out with this one. Okay, minus 3 and 3 is there. So how much is there? 0.5 by 10 is there, right? So 5 by 10 is, how much is there? We can say that 0.5. Okay, 0.5. So we can say tan theta is equal to, here you will get tan theta is equal to 0.5. Am I right? So the theta is going to be equal to tan inverse 5. It's very clear. So theta should be equal to tan inverse of 0.5. So which option matches? You can see that theta is equal to tan inverse 0.5, right? Tan inverse 0.5. The fourth option is the right answer. I hope all of you understood this.